Hello, I'm Sanchez from the Technical University of Madrid, and I'm going to present you our work, High Tenacity Thermoformable Recycled Rubber Material, Recycling as Added Value in Construction. Every day we see more initiatives focused on sustainability everywhere. A clean urban mobility, for example, seeks to cut CO2 emissions from our vehicles, and yet the electric cars continues generating a vast amount of waste that keeps polluting our planet. On this regard, global demand for pneumatic tires in 2018 was over 1.6 billion units. This car tire rise above 1.5 billion, from which we recover less than 60%, and the rest ends up its life cycle in landfills or in wastelands. One thing to keep in mind is that each ton of waste rubber abandoned in a wasteland produces around 35 kilograms of CO2 emissions. The chemical stable structure of rubber confers the material a slowly degradation and also an insulating and water repellent properties. This feature appears to be of great interest in the construction sector, where recycled rubber is commonly used to manufacture mortar and coating applications, asphalt productions, urban furniture, constructive elements, among others. However, depending on the percentage of rubber, some materials can present a, a brittle breakage, like this on the image, due to the differences between the elastic model of its components. This work is about the design and development of a new composite material using recycling rubber as main aggregate in a matrix of sulfates and polymeric resins. We've been inspired by the composite materials from naval industry as they represent an unexplored opportunity for the development of new constructive materials. The initial experimental procedure consisted of identifying the best aggregates, fillers, and reinforcements to produce a freeform facade material, resulting in a mixture designed with 32 different proportions, varying from 27 to 32% of resin, 52 to 56% of recycled rubber, and 19 to 26% of aggregates and fillers. The materials used were unsaturated polyester resin, recycled rubber in different sizes, fire stabilizers, fillers, sulfate derivatives, and natural and synthetic fibers as reinforcements. The manufacture method consisted of dividing the recycling rubber into different sizes, washing and drying the rubber, mixing the sulfates, the fillers, the fire retardants with the resins, adding the recycled rubber to the mixture, pouring the mixture over a wrapping fabric, spreading the mixture evenly inside a mold, wrapping the mixture and applying a weight on top of the mold, putting the mold into a drying oven to boost and control the curing process, unmolding the resulting plates, and once cured, the plates were weighted, sized, and stored for 28 days before being tested. The type of aggregate determined the final properties of the specimens. While the fillers did not produce any physical reaction, the rest of the materials affected both the physical characteristics and the mechanical properties. Also, a higher percentage of resin didn't mean an improvement of strength. Physical and mechanical tests demonstrate that the material has a low density of about 0.09 grams per cubic centimeter. And this stress strain graphic from the mechanical experiments reveals the ductile behavior of the material, showing the highest resistance to bending at around 2.74 megapascals. That is similar to those commercial construction elements made of plaster and fibers. The transmittance test showed that experimental material has a low thermal conductivity, varying from 0.06 to 0.08 watt square meter Kelvin. The most interesting feature of the produced material resides in the possibility of adopting any desired shape, and also its ability to remain in stress after its first crack. This is due to the internal rearrangement of the material and the reinforcing fibers. Although it is necessary to make some improvements, the results demonstrate that the material design can be used to produce free-shaped constructive elements, representing an attractive option for the construction sector, where newer architectural projects increasingly rely on unique constructive elements with a non-linear morphology. Thank you very much for your attention.